Okay, now we're going to go to anomalous electronic configuration for chromium and copper. So, your chromium and copper, okay, have electronic configurations which are inconsistent with Aufbau principle. Maksudnya, chromium dan copper ni special case. Okay, anomalous ni maksudnya special case. Dia tak ikut kebiasaan. Dia tak ikut Aufbau principle in this case. Okay, dia adalah luar biasa punya case. Alright, special case lah kira, special case. So, the anomalies are explained on the basis that a filled or half-filled orbital is more stable. Okay, so this anomalous case for chromium and copper, it happens because of stability of half-filled and filled orbital. Okay, so filled orbital and half-filled orbital are more stable than partially filled orbital. Okay, so macam kalau ada kotak macam ni, okay, a partially filled orbital looks like this. Ting, ting, macam tu. Okay, ini adalah partially filled orbital. Bila awal letak satu lagi, this is half filled orbital. Okay, so bila awak tambah macam ni, it is partially filled. This is partially filled. Bila awak tambah lagi satu, this is fully filled or completely filled. So, very stable lah. Okay, so let's look at the stability of orbital. Okay, for degenerate orbitals, orbitals of the same energy, macam whatever, P, 2P, 3P, 4P, 3D. Okay, kira 3P, 3D lah contohnya kan, contoh. Half-filled orbitals is more stable than the partially filled. Okay, so let's say kat sini, how do we draw, how do we show half-filled orbital? Half-filled orbital in this case for, let's say, p orbitals will look like this. 1, 2, 3. So ini dikira half-filled. Okay, so this is more stable than this on your right. 1, 2, 3, 4. Ini adalah partially filled. Okay, for D orbital pula, okay, let's say I want to use color blue. Half filled looks like this. 1, 2, 3, 4, 5. Okay, this is half filled D orbitals, and a partially filled orbital will look like this. 1, 2, 3, 4. Ini partially filled, ini half filled, ini partially filled, partially filled. Okay, so asalkan dia tak full tu maksudnya dia partially filled lah. Okay, so nampak tak gambaran between half filled dengan partially filled? Okay, half filled maksudnya dia tinggal setengah saja lah yang isi. Okay, semua singly filled. Partially filled dia ada kosong-kosong sikit, kosong-kosong-kosong. So this partially filled is less stable compared to half filled orbitals. Okay, so apa kena mengenai dia dengan chromium dengan copper? Okay, kalau kita ikut kebiasaan, we will follow Aufbau principle, right? So let's say for electronic configuration for chromium 24, the electronic configuration is this: 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d4. Tengok sini, 4s2, 3d4. So if you draw the orbital diagram, okay, for chromium 24, you can, ini fill macam biasa. But right here, you can see that you have 4s2 and 3d4. Okay, if you notice here, okay, this 3d orbital right here, this 3d orbital right here, it is partially filled. Okay, so this is less stable compared to if you have half filled or fully filled. Okay, this is partially filled. So this is what we expect Okay, if we follow the Aufbau principle, we expect the electronic configuration for chromium to be like this, right? But that is not the case. What actually exists in a real life is that chromium 24, okay, to achieve stability, one of the electron from 4s here, okay, will occupies one of the 3D orbital in order to have a half-filled orbital arrangement seperti di bawah ini. So basically, bukannya this electron moves tau, tapi macam this one is expected, but this is not what you have in the ground state for chromium. Okay, sebenarnya, actually, this electron does not occupy the 4s orbital, but it actually occupies the 3D orbital here. Okay, so basically chromium 24 has a half-filled 3D orbital. Okay, so it exists this way. Okay, so this is a special case. Dia tak follow Aufbau principle. Kalau follow Aufbau principle, kita memang akan fill in our lower energy orbital, which is 4s first before 3D. Okay, but for chromium 24, we don't follow Aufbau principle because of the 3D half-filled 3D orbital stability. Okay, so the actual SPDF electron configuration for chromium 24 is 1s2, 2s2, 2p6, 3s2, 3p6, 4s1, 3d, 5. Okay, so kita nampak lah kat sini kita ada half-filled 3D orbital arrangement which increase the stability of chromium atom. Okay, so this is the actual electronic configuration for chromium 24. Same case as copper, but it is not half-filled dalam case copper ni. Okay, so kalau based on Aufbau principle, the electronic configuration for copper 29 is 1s2, 2s2, 2p6, 3s2, 3p6, and then for s2, 3d9. Okay, so awak cubalah lukis, draw the orbital diagram, and you will see that your 4s and 3d 1, 2, 3, 4. Okay, you fill in your electron. It is 4s2, 3d9, 5, 6, 7, 8, 9. Okay, 3d9. So if you look here, okay, this 3D orbital is a partially filled 3D orbital. Okay, so this is what is expected to have a partially filled 3D orbital. But actually, copper 29, the electronic configuration, okay, awak lukis ni semua, dan the 4s and 3D. Okay, it is actually 4s1, 3d, 10. Okay, so maksudnya instead of partially filled 3D orbital, you have a fully filled 3D orbital. So a fully filled 3D orbital is much more stable than a partially filled 3D orbital. Okay, so the actual SPDF electronic configuration for chromium pula, ini copper ya, copper 29 is 1s2, 2s2, 2p6, 3s2, 3p6, 4s, 4s1, 3d, 10. Okay, so yang tu awak complete kan. Okay, so this is basically the conclusion. To conclude the anomalous cases of chromium and copper, diorang tak follow Aufbau principle. Kalau ikut Aufbau principle, this is the electronic configuration, but actual SPDF notation for chromium and copper respectively is this. Okay, so basically kita punya reason is that for here 3D orbital is half filled, okay, meaning that it is more stable compared to partially filled 3D orbital of chromium. Okay, ini fully filled, okay, is more stable. 3D orbital which is fully filled is more stable than partially filled 3D orbital of copper. Okay, okay, so last sekali we are going to learn how to fill in electrons and remove electrons from transition elements. Okay, kalau bukan transition element, macam for elements of S block and P block, okay, kita tak ada masalah sangat. Contoh macam fluorine kan, fluorine atom, kita tahu kalau dia atom maksudnya dia ada 9 elektron juga. Okay, so kalau dia punya SPDF notation, it will be 1s2, 2s2, 2p5. Okay, kalau dia ion, okay, nampak tak ni ada minus charge ni, so that means that you have more electrons lah. So maksudnya awak ada 10 electrons kan. So kalau macam tu, it will be 1s2, 2s2, 2p6. So macam biasa je lah. Okay, kalau S block dengan P block, you add electron macam biasa. Okay, kecuali copper dengan chromium lah, during this special case. But if we have transition elements like cobalt here, okay, if you fill in your electrons, okay, 27 electrons for this atom, cobalt atom, okay, it will be 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d7. Okay, tengok sini. So sekarang ni, okay, bila kita nak remove pula electron, okay, when you want to remove electron, you will remove electron from the orbital with largest n value. Okay, so maksudnya kita akan remove 3 electrons tu dari mana? Okay, kalau kita lukis kan, kita punya orbital diagram for 4s, ini saya just tunjuk je, 2, 3, 4, 5, 3D. Okay, and we have 1, 2, 1, 2, 3, 4, 5, 6, 7. Okay, so we will remove 3 electrons. So kita nak remove dari mana? Adakah kita akan remove dari sini ketiga-tiganya? Tak, kita akan remove daripada largest n. Okay, maksudnya 4s punya. Kita akan remove 2 of these electrons. Okay, lagi satu elektron kita remove lah daripada 3D, which is this one. So then our SPDF notation for cobalt 3+, 3+ maksudnya dah remove 3 elektron, it will be 3p6. So remove yang ni dengan satu dari sini, so it will be 3d6. Okay, so maksudnya awak punya ni kan, your kotak ni tadi, paste. Okay, awak remove elektron mana? You will remove 2 electrons, 1 electron from, sorry, bukan ini, this one. Okay, so sekarang ni awak punya 4s orbital dah kosong lah. Okay, lepas tu kat sini awak tinggal 6 electrons je dalam 3D orbital. Okay, so that's how you remove electrons from transition elements. You remove from the largest n. Okay, so that means instead of yang daripada 3D ni, awak remove 2 elektron daripada 4s dulu. Okay, higher n value, right? So that is basically it. So this is your list of electronic configuration for transition elements. Okay, kat sini just nak tunjuk yang chromium dan copper ada special case. Alright, dia orang je yang ada 4s1 ni, tapi dia ada 3D5 dengan 3D10, half filled dengan fully filled. That's why macam tu. Then this exercise you will do it on your own. Okay, alright, so that's all for chapter 2. I will meet you guys tomorrow and we will discuss the examples and exercises as well as the remaining tutorial questions from your tutorial book. Okay, so finish up your chapter 2 tutorial. Thank you. Bye bye.